So if you imagine for a second that you're standing in this massive high-tech control room,
Right.
and on the left side of the room, you've got this giant wall of monitors
Yeah.
just showing absolute global chaos.
Yeah, just red flashing everywhere.
Exactly. I mean, we're looking at the Koda Daily Intelligence Brief and the internal production scripts from today, which is April 7, 2026. And the facts on the ground are, well, they're stark.
Extremely.
You've got U.S. President Trump setting a midnight EDT deadline for Iran to accept this Pakistan-brokered ceasefire.
And reopen the Strait of Hormuz.
Right, reopen the Strait of Hormuz, or else they're threatening severe infrastructure strikes.
Yeah.
And Iran has sternly rejected the truce they're vowing to escalate.
And you've already got Israeli airstrikes hitting Iranian infrastructure across places like Tehran, Avaz, Shiraz.
Yeah, and the markets are just plunging. The sentiment tracker is flashing extreme fear. And oil spiked to, what, $108.54 a barrel.
Which is just wild to see in real time.
It's totally overwhelming. But, and here's the thing we're doing today, if you turn your head to the right side of that control room,
A completely different picture.
completely different. You see blueprints for digital infrastructure on a scale humanity has literally never attempted. You see massive talent recruitment, safety protocols being coded,
Two entirely different realities.
happening at the exact same time. And, you know, we're going to skip the whole infrastructure under threat framing today because, honestly, we've hammered that for 2 days running.
Yeah, we've covered the panic.
Right. Today, for this deep dive, we are focusing on what the biggest tech builders are doing despite the chaos. How the AI industry is looking at global instability and saying, this isn't an existential threat, it's just an engineering problem.
Which is such a fascinating mindset shift. Because if you let the panic dictate your view, you miss the actual structural shifts happening beneath all that noise.
So let's look at how they're engineering around it, because the biggest development in this brief is this new Anthropic, Google, and Broadcom compute alliance.
Yes.
They aren't scaling back at all. They're forming a three-way strategic partnership to secure multiple gigawatts of next-gen compute capacity.
And we really need to pause on that word gigawatt.
Right, because it's hard to visualize.
It is. I mean, just to understand the physical scale of this, but a single gigawatt is roughly the power consumption of an entire mid-sized city.
Wow.
Or, you know, about 3.1 million solar panels running at absolute peak capacity.
And they are securing multiple gigawatts.
Multiple, specifically to train frontier models far beyond what we have now, using next-gen custom AI chips.
But wait, let me just play devil's advocate for a second. Because in the same brief, we see reports of Iranian drones hitting the Sabic petrochemical complex in Jubail, Saudi Arabia.
Right, causing a massive fire at a huge industrial site.
Yeah, so if a cheap drone can take out a petrochemical plant, isn't a multi-billion-dollar gigawatt data center just a sitting duck? Like, why accelerate physical builds when energy infrastructure is clearly so vulnerable?
Well, if we connect this to the bigger picture, they view that physical vulnerability as a variable, not a roadblock.
A variable, okay.
Yeah, they aren't pausing the builds because a drone hit a plant next door. Actually, they're using that strike as the exact reason why geographic and energy diversification is paramount right now.
Oh, I see.
They're spreading these facilities out. They're building redundant power grids, investing in next-gen nuclear and geothermal. So if one pipeline or one choke point gets hit, the system survives.
Okay, let's unpack this. It's almost like a maritime logistics coordinator who's trying to move cargo ships around a storm.
That's a great way to put it.
Like, if the Strait of Hormuz becomes dangerous, you don't just stop all global shipping forever.
Right, you don't just quit.
You pull out the map, you look at the variables, and you just engineer a new route.
Exactly. Resilience through redundancy and scale. They acknowledge the chaos in the Gulf, but they're designing the physical hardware to be hardened against it.
So a disruption in one region doesn't stop a global training run. But, you know, a gigawatt of power flowing into a million chips doesn't actually do anything on its own.
It's just a very expensive space heater.
Exactly. It's useless without human minds to program it. And that really brings us to the human capital side of the brief, which we really want to emphasize today. Because mid-crisis, the numbers are getting entirely surreal.
Oh, the talent war is escalating dramatically.
UB Tech, the Chinese robotics company, is currently offering an annual salary of approximately $18 million to recruit a single top AI scientist.
$18 million. for one individual.
Just staggering.
And the specific focus of that hire is key. They're paying that bounty for a researcher working on embodied intelligence.
Right. And let's break down embodied intelligence real quick for anyone not deep in the robotics weeds.
Yeah.
Because I think people see ChatGPT writing Python scripts and think, well, making a robot fold laundry should be easy.
Which is exactly what Moravec's paradox is all about.
Moravec's paradox.
Yeah, it's this observation that high-level reasoning requires very little computation. But low-level sensor-motor skills like moving around require immense computational resources.
So passing the bar exam is easy for AI.
Very easy. But getting an AI to walk across a messy living room, pick up a glass of water, and hand it to you without crushing it, staggeringly difficult.
So embodied intelligence is basically bridging that gap between the digital brain and the physical world.
Exactly. And that $18 million salary tells us the bottleneck isn't just compute power anymore. It's the sheer, rare human brilliance needed to break through our current algorithmic plateaus.
They're essentially saying, we've got the gigawatts, now find me the one person who can make the robot walk.
Yep.
But here's where it gets really interesting, right? Because OpenAI simultaneously launched their safety fellowship.
A really massive counterweight to all this speed.
Yeah, this is a dedicated program funding cross-org collaboration. They are paying researchers to work entirely on AI safety challenges. So they're institutionalizing safety protocols right in the middle of this multi-million-dollar talent sprint.
And that simultaneous investment is deeply intentional. I mean, think about it. You've got intense geopolitical tension. You've got this crazy talent war where researchers are getting athlete-level money, and yet
They're still pouring resources into oversight.
right. Shared safety frameworks, alignment. They're treating safety as a core part of the engineering process itself, not just some afterthought slapped on at the end.
It's like building a Formula One car. You don't just spend $18 million on the engine and the driver.
You'd crash immediately.
Right. You have to invest equally in the brakes. The safety fellowship is the brakes, so you can actually drive at 200 miles an hour without flying off the track.
That's exactly it, because the reaction fundamentally wants to go critical. The gigawatt compute and the talent are pushing for infinite speed.
And nobody wants to stop the speed.
No, nobody wants to turn the reactor off. So these safety frameworks are like the control rods in a nuclear reactor, absorbing the excess heat so we get usable electricity instead of a total meltdown.
That makes a lot of sense. The containment vessel has to be just as advanced as the fissile material inside it.
And we have to talk about the speed of that reaction, because the output dropping from these labs right now it's almost difficult to track.
The friction in software development is essentially collapsing to zero.
Completely.
Let's look at Meta. The brief shows they've shipped 4 different generations of their MTIA custom inference chips in just 24 months.
4 generations in 2 years.
Which used to take a decade.
Right, and we should probably distinguish what an inference chip does versus a training chip, just to understand why this speed is so critical.
Yeah, break that down for us.
Think of training a massive AI model like sending someone to medical school.
Okay.
It takes years of intense studying, massive amounts of energy to learn everything. That's the training phase.
Lots of gigawatts.
Exactly. But inference is what happens after graduation. It's the doctor sitting in the clinic answering patient questions.
Oh, get it.
It requires a totally different type of processing power. So by rapidly iterating these MTIA inference chips, Meta is drastically lowering the cost and increasing the speed of running these models for billions of users every single day.
And that hardware acceleration is feeding this incredible software explosion. I mean, the Hugging Face Spring 2026 report tracked over 30 distinct open-weight model launches in March alone.
Just in March.
Yeah, dozens of labs globally, just releasing highly capable models back-to-back.
And that term open weight is a crucial distinction here.
How so?
Well, when a company releases an open weight model, they are providing the final trained parameters, the actual neural network connections and learn-in knowledge.
Right, so developers can just download it and run it.
Exactly. They aren't necessarily releasing the raw training data or the exact code used to train it, which is why it's not the same as pure open source software.
Okay, that makes sense.
But by giving you the weights, they're handing developers a fully baked, incredibly powerful brain to build on top of.
Which is a huge head start. And Microsoft is jumping into this flood too with their MAI model family.
The MAI releases are huge.
Yeah, they dropped MAI Voice 1 for speech synthesis, MAI Image 2 for images, and honestly the most staggering one, MAI Transcribe 1.
The transcription cost drop is historic.
It drove the cost of the most accurate speech-to-text system available down to 36 cents per hour.
36 cents.
I mean, let's pause and think about what happens to the global economy when perfect auditory comprehension costs 36 cents an hour. Entire industries, transcription, medical dictation, legal documentation, they're entirely upended overnight.
It forces a total reallocation of human labor, because when transcription drops to pennies, the value is no longer in converting audio to text.
Right, the value shifts entirely to what you do with the tech.
Exactly. How do you analyze it? How do you act on it? This collapse in the cost of basic cognitive tasks is paving the way for tools that fundamentally alter how we create things.
So what does this all mean? Like, for the tools in the brief that genuinely blew my mind, Blink.new and Aider.
Oh, Blink.new is incredible.
Right. If you're sitting at your desk wondering how these gigawatt alliances affect your daily life, look at Blink.new. It's an AI-powered full-stack app builder. You don't write a single line of code.
None.
You just type a plain English prompt. You literally say, build me a secure inventory management web app with user logins and a dark mode. And it instantly generates the mobile app, the web interface, the back-end database, the API connections.
It's all just there.
You just review it and hit deploy. It's like having a whole senior development team living inside your browser window.
We are literally watching the barrier to creation drop to near zero. Historically, if you had an idea for software, there was this massive wall of friction.
You had to know how to structure a database or write front-end code.
Or hire people who did, which meant needing significant capital. Tools like Blink.new remove that friction entirely. The premium is now completely on the quality of your ideas, not your ability to execute the syntax.
And then you have Aider, which attacks it from the deep technical side.
Aider is fascinating for developers.
It's wild because it's a command line interface coding agent. It works directly with your Git repository. If you like working in the terminal, you just point Aider at some incredibly messy legacy code module from 5 years ago.
We all have those.
Right. And you just tell it to refactor the whole thing to modern standards. It understands context, makes structured edits across multiple files, and commits the changes cleanly, frictionless maintenance.
And that connects directly back to why those gigawatt data centers are being built in the first place.
Because it takes power to do that.
Exactly. All this seamless creation, the full stack apps from a single sentence, the terminal refactoring, the 36-cent transcription, it requires immense continuous compute power in the background. The user experience is magic, but the backend relies on industrial-scale energy grids.
And this isn't just happening in a Google server farm. If you're listening to this right now, you can open tools mentioned in the sources, like Tether AI or Workflow Machine, and schedule one of these agents to clean out your inbox.
Or pull competitive analysis reports.
Yeah, or triage your incoming request by 5 p.m. You can schedule your own personal AI agent to handle recurring tasks. The multi-billion-dollar compute cluster is essentially acting as your personal intern.
It's the democratization of enterprise-grade capability, trickling all the way down to your daily to-do list.
It's amazing. But, there is a ceiling to all this silicon, isn't there?
There is. Even with gigawatt data centers and custom inference chips, you eventually hit a physics problem with traditional computing.
Heat
And energy efficiency. Silicon can only be pushed so far. And that physical limitation is what drove the most science fiction aspect of this briefing.
Oh man, we have to talk about the biodigital frontier. Because Meta AI just released something called Tribe V2.
This is where it gets truly futuristic.
It's a predictive foundation model. But it isn't predicting text like a standard LLM. Like standard LLMs just predict the next logical word based on the internet. They don't actually think.
Right.
But Tribe V2 is trained on actual human brain responses to visual, auditory, and linguistic stimuli. It's mapping and simulating biological neural activity.
This raises an important question about the convergence of synthetic biology and AI, because they are essentially trying to reverse engineer the biological algorithms of the human brain to build better artificial systems.
Yeah, mind-blowing.
If you can map the actual electrical signals of a human brain while it processes a problem, you aren't just teaching an AI to mimic speech. You're teaching it the biological mechanics of reasoning.
Meta is trying to make silicon act like a brain.
Exactly.
But then you have Harvard researchers coming at the problem from the exact opposite direction. Their work, which was just published in IE Spectrum, details the creation of microscopic neurobots.
Yes, living robots.
Actual living robots equipped with functional nervous systems. They are biological machines that sense and respond to their environment using biological neural signaling, not electronic circuits.
And, for decades, the paradigm has been about mimicking biology using silicon and copper.
Right.
We are moving past that. We're entering an era where biological tissue living cells is literally being used as the hardware substrate itself.
Wait. So instead of teaching a computer chip to think like a bug, we're just giving a microscopic biomachine a job.
Basically, yes.
It's almost like we're domesticating cells to run our code. We're treating living neural tissue like a programmable microchip.
Domesticating cells is an incredibly precise way to frame it. I mean, we've domesticated plants and animals for millennia to perform labor, right?
Sure.
We are now domesticating the foundational building blocks of life to perform computational tasks at a microscopic level.
That's wild.
The implications for targeted medicine, environmental monitoring, next-gen computing, they're staggering. Biology is the most efficient information processing system we know of. The human brain runs on about 20 watts of power.
Which is like a dim light bulb.
Exactly. Compare that to the gigawatts required for an AI data center. By integrating functional nervous systems into microscopic robots, researchers are leveraging millions of years of evolutionary engineering to solve the power crisis of modern computing.
It is a phenomenal spectrum of engineering. I mean, on one hand, you have Broadcom and Google forging gigawatt alliances that look like sci-fi megastructures to bypass supply chain threats.
Yep.
And on the other hand, researchers programming microscopic living nervous systems to act as robots.
And all of this is fueled by the same underlying momentum. The industry operates on the fundamental belief that intelligence, whether it's distributed across a gigawatt server farm embodied in an $18 million robotics project or grown in biological tissue, is the ultimate tool for solving complex problems.
Which brings us back to where we started. If you look at the headlines today, the narrative arc is just dominated by extreme fear.
Chaos, midnight ultimatums, 108 oil.
Plunging markets. It feels so chaotic. But beneath that noise, there is this unstoppable engine of informed optimism. Builders are forging gigawatt compute alliances as a deliberate bet that instability is just an engineering problem.
Absolutely.
They're paying $18 million for brilliant minds. They're institutionalizing safety with global fellowships, putting the brakes on the Formula One car mid-race.
Building the control rods.
Right, and they're driving the cost of creation down to zero, so you could build full-stack apps with a single sentence. Plus, literally building living biological robots. The future is being engineered right now in real time.
The physical reality of tomorrow is being codified today, completely independent of the geopolitical theater.
And that leaves us with a final thought for you to ponder on your own. We talked about how the physical infrastructure of AI is surviving global conflicts through gigawatt-scale redundancy.
Right, rerouting power like ships around a storm.
Exactly. But what happens when the AI safety frameworks we talked about become just as decentralized and resilient?
Oh, that's an interesting thought.
Right. Will we eventually see a global safety grid, like an automated decentralized network of guardrails that instantly and automatically reroutes around bad actors and malicious code the exact same way physical supply chains reroute around physical threats?
A self-healing safety infrastructure.
Think about what that would actually look like.
It's likely the next great engineering hurdle.
It really is. Well, thank you so much for joining us on this deep dive into the Koda Daily Briefing. We'll catch you next time as we keep exploring the blueprints of tomorrow.